Hey guys, today we're going to be talking about compound inequalities. Now, sometimes they're known as and/or inequalities. Well, as you can see in the problems, we have the word and or. Now, you're probably familiar with the fact that compound inequalities usually look something like an interval of numbers that x could be equal to, or maybe the opposite of an interval. X could be anything except this little range, right? So let's talk about how to solve each of these. Now, first off, we have an and inequality. That means that we're going to be working with what I like to call an interval. Now, we'll figure out that interval here in a bit. But the first thing we want to do is just solve each of these inequalities separately, just like we would a normal inequality. So let's do that. We want to get x on its own, so we'll subtract 7, get 2x is greater than 2, and to get x on its own, divide by 2 and find that x must be greater than 1. Okay, great. There is one of our inequalities solved. Let's solve the other one. So again, to get x on its own, we need to get rid of this 1 and need to get rid of that 3. Add 1 to the other side to get 3x is less than 21. And then to get x on its own, let's divide by 3 and find that x is less than 21 over 3, or 7. So here's our other inequality. Now we need to make an interval from those. In other words, a thing saying x is between this and this. That's what an and inequality will look like. So here's what I like to do. I like to take the smaller number, the number that it says x is larger than, and I'll write it first. Next, I'm going to have a less than sign here, and then I will put my x. This says the same thing as that, right? We just kind of reversed its order. And then we're going to put this on the other side. X is less than 7. This shows me my interval. X needs to be somewhere between 1 and 7. I know it now. I found my compound inequality. Again, just to reiterate how we got this answer, we took our numbers, we put the smaller one on the left, the larger one on the right, x is in the middle. These two signs will always be less thans or less than or equal to, depending on what you have here. If this would have been an or equal to sign, then the one next to the 1 would have been or equal to as well. That's the only time that changes. If we wanted to put this on a number line, we can. So the way I personally like to do it is I'll just put a 1, I'll put a 7, I'm going to say open dot or open circle because it is not or equal to. I'm going to do open circle because again, not or equal to. And since 1 is between them, since that's our interval, x can be anything in there, I'm going to fill in my line between those two numbers, just like that. There we go. Now let's take a look at this second problem. Just to spice things up a little, I am going to add an or equal to sign in here, so one little change. But let's solve each of these as well. So, or problems are no different. We solve each inequality separately. So, minus 2, get 5x is less than or equal to 10, and then divide by 5. So we get x equals 10 over 2, or 10 over 5, otherwise known as 2. Now I accidentally wrote equals. That should be, of course, less than or equal to. We can look at the second inequality and solve it as well. Let's add 1 to the other side. Get 2x is greater than 6, and then divide by 2. That gets x on its own, and 6 over 2 is 3. So there's our other statement. X must be less than or equal to 2. but x must be greater than 3. Now, since this is an OR problem, we don't do this interval. We don't do that kind of range of values, because we're going to realize when we put this on a number line, it's kind of the opposite of that. In an OR problem, what you are going to do is you are going to plot your inequalities separately. I'm still going to put marks at my two numbers, so 2 and at 3. But I'm going to graph this one first. X is less than or equal to 2. So I'm going to put a circle at 2 and fill it in because or equal to. And then since x is less than, that arrow is going to go to the left. When I take a look at my second inequality, x is greater than 3. An open circle at the 3, and then since x is greater, that arrow going to the right. And this is what it'll look like. This says x can be anything over here, anything less than 2. It can't be between these two numbers. There's that one little spot where it can't be. And then it picks back up again and it says it can be anything bigger than 3. So there's a lot of numbers x could be, just can't be anything between those. So this is an AND problem. You get that interval. This is what your number line should look like approximately for an AND problem. This is an OR problem, and this is approximately what your number line should look like for an OR, where your arrows are going in either direction. If you have any questions about this, feel free to drop them in the comments below. Otherwise, I'll see you guys next time. Thanks for watching.